Hello students, let us solve problems from practice set 5.3 from the topic probability of class 10th. Let us have the question. Write the sample space S and the number of sample points n of S for each of the following experiments. Also write events A, B, C in the set form and write n of A, n of B and n of C. So earlier we have studied what is sample space, number of sample points and the experiment. So for this question, some experiments are given. For those experiments, we have to write the elements of those experiments in set form, and also we have to write the number of elements in each set. So let us have the first experiment. One die is rolled. So this is the experiment, and there are three events given: event A, event B and event C. Event A is even number on the upper face, that is when one die is rolled, we have to find the sample points in which we get even number on upper face. Event B is odd number on the upper face and event C is prime number on the upper face. So first of all, for this random experiment, we have to write the sample space. So as one die is rolled and we know that the die has 6 surfaces, that means we can get any number from 1 to 6 on the upper face. That's why sample space S is equal to, in curling bracket, 1, 2, 3, 4, 5 and 6. So here 6 elements are there in this set. That's why n of S is equal to 6. So this is the sample space for the random experiment and the number of sample points are 6. Now let us consider the first event, that is event A. We should get even number on the upper face. So for this event, we have to find the number of elements we can get. So in set A, we should have 2, 4 and 6, because out of numbers 1 to 6, there are only 3 numbers 2, 4 and 6 which are even. That's why for event A, the elements would be 2, 4 and 6. So as there are 3 elements in this set, that's why n of A is equal to 3. Now let us consider the second event, odd number on the upper face. Now if we observe this sample space, we have numbers from 1 to 6. We have to find out odd numbers from these. So the first odd number is 1, then 3 and 5. So B is equal to, in curling bracket, 1, 3, 5. These are the 3 elements we can get. That's why n of B is equal to 3. Now the third event is event C, prime number on the upper face. Now we have to find prime numbers from the sample space. So as we know that 1 is not prime number. So the smallest prime number is 2. So we should have in set C 2, 3 and 5, because these are the only prime numbers amongst 1 to 6. That's why in set C we get elements 2, 3 and 5. Therefore n of C is equal to 3, as there are 3 elements in this set. So these are the events and the number of sample points in those events. Let's have the next experiment. This time 2 dice are rolled simultaneously. We have to find sample space and the number of sample points for that experiment. And the event A is given, the sum of digits on upper faces is a multiple of 6. Event B is the sum of digits on the upper faces is minimum 10. And event C is the same digit on both upper faces. So first of all, for this random experiment, that is 2 dice are rolled simultaneously, we have to write a sample space. So the sample space, which is denoted by letter S, we have these 36 possibilities that we get when 2 dice are rolled simultaneously. That means the first possibility is there, in which on both the die we can get a number 1. For second one, we can get on the first die 1 and on the second die 2. In this way, we can get up to 6. So these are the 36 sample points for this sample space. Therefore, n of S is equal to 36. I'll consider event A, which is the sum of digits on upper faces is a multiple of 6. So these are the pairs of numbers that we get when 2 dice are rolled. We have to find out those possibilities for which the sum of digits on upper faces is a multiple of 6. We'll name that set as A. Now if we observe all these sample points, we have the first number, that is 1, 5. If we add these two, 1 plus 5, that's 6. and 6 is a multiple of 6. That's why we have taken the first point 1 5. Then if we observe the second row, from this we can get only 2 4, because the sum of 2 and 4 is 6, which is a multiple of 6. So this is the second sample point. In the third row we can get 3 3. Then in the fourth one we can get 4 1. Then we have 5 1. And in the last row we have 6 6, because 6 plus 6, that's 12, and 12 is a multiple of 6. So these are the 6 elements are there which satisfy the given condition. That's why here n of a, that is number of sample points in set A, is 6. That's why n of a is equal to 6. The second event is the sum of digits on the upper faces is minimum 10. Now here one condition is given that the sum must be minimum 10 and maximum, no condition is applied here. That's why it can be, the sum can be more than 10. So we have to collect those points whose sum is 10 or more than that. So the set B contains elements 4 6, 5 5, 5 6, 6 4, 6 5 and 6 6. So if we add any two numbers from each pair as 4 plus 6, that's 10, which is minimum of 10. Then 5 plus 5, it is also 10. Then we have 5 plus 6, that's 11. So it can be a part of this set because we need the sum of digits 10 or more than that. So we can have that point. Then 6 4, again 6 plus 4 is 10. 6 plus 5 is 11. So that can be also part of that set. And 6 plus 6, that's 12. So these are the only elements from these 36 sample points which satisfy the given condition. That means the sum of these digits only is 10 or more than that. 6 sample points are there in this set. That's why n of b is equal to 6. Event C is the same digit on both the upper faces. Here the first element is there. We have to check out the sample space and each sample point in which there is the same digit on both the faces. So the first element is 1 1. In the second one it has 2 2. In the third row it is 3 3. In the fourth row it is 4 4. In this way we get set C is equal to 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. So these are the again 6 elements are there in set C. That's why n of C is equal to 6. So these are the number of sample points in each events that are given to us. Next random experiment is one coin and one die are thrown simultaneously. And event is given here. Event A, to get head and an odd number. Event B is to get head or tail or an even number. And event C is number on the upper face is greater than 7 and tail on the coin. To find these events, first of all we should find the sample space for this random experiment. Now the random experiment is one coin and one die are thrown simultaneously. So if we toss a coin, we can get either head or tail, and if we throw a die, we get any number from 1 to 6 on the upper face. So for this random experiment, we have the sample space as h1, h2, h3, h4, h5, h6 as head on the coin and the number on the upper face of the die. The first possibility would be h1, h2 up to h6, and if we consider tail on the coin and the numbers on the die from 1 to 6, then the possible outcomes are t1, t2 up to t6. So these are the 12 sample points for this sample space. Therefore, n of s is equal to 12. The first event is to get head and an odd number. Now we have to find those sample points from this sample space which has head on the coin and which has odd number on the upper face of a die. So here if we go on checking from the first element h1, that can be a part of set A as head is there on the coin and the number is 1 which is odd. That's why h1 is the first element. We cannot take h2 because though there is head on the coin, but the number on the upper face of the die is 2 and 2 is not an odd number. That's why it cannot be a part of our set. Next element would be h3 as both the conditions are satisfied here, and after that we have h5. So these are the only 3 possibilities which satisfy the given condition, that is to get head and odd number. So n of A, that is number of sample points in set A, are 3. That's why n of A is equal to 3. Event B is to get head or tail and even number. Now here either we can get head or tail on the coin, and the number on the upper face of a die must be even number. So set B has elements H2, H4, H6 as head on the coin, and number is even, that is 2, 4, 6. These are the even numbers. On the coin we can have tail also. That's why we should take T2, T4 and T6 also in this set. So in all we get 6 elements. That's why n of B is equal to 6. Let us have the next event C. The number on the upper face is greater than 7 and tail on the coin. Now we need a number on the upper face which is greater than 7. And as we are throwing a die, and die has only 6 surfaces, no 7 surfaces there. So we cannot get number on the upper face greater than 7 in any condition. That's why this set C does not have any element, as a die can have only 6 faces. That's why we can have only 6 numbers on the upper face. That's why set C would be empty set. Therefore, n of C is equal to 0. So there are no such elements which satisfy the given condition. That's why n of C is equal to 0. That is, set C is an empty set.